Alright, so let's consider this example here. We have a polynomial on top, and we have this stuff on the bottom to the 3/2. Okay. This polynomial on top is a little concerning, like how everything is going to kind of work out, but for the moment, I focus on this stuff down here in the bottom, where again, standard letting u be the denominator stuff just doesn't work, right? Because it don't have the derivative of that stuff on the top. So I see this quantity inside here, and I think, well, let's try to complete the square with that. Let's try to complete the square with that. Okay. So rewriting that so that the x squared comes first, I'd have negative x squared plus 8x, right, plus 9. Okay, and so again, remember, for our completing the square, the x squared can't have anything in front of it, even a simple little negative sign we have to take care of. So I can factor that out, x squared minus 8x, leave myself a little bit of space, and then plus 9. So I factored the negative out from the x squared and the 8x, and that left me with x squared minus 8x. And then we use our completing the square process. Take half of the minus 8x, that gives me a negative 4. That gives me a negative 4. Negative 4 squared would be 16. So to complete the square here, I need to add 16. Okay. But what I really did is I really added a negative 16, because the negative sign out front. So on the outside, I have to also add a 16. I have to also add a 16. And then we simplify this. We'll factor as x minus 4 quantity squared plus 25. Okay. Which I can write as 25 minus x minus 4 quantity squared. And so that I see now that I am once again in the form a squared minus x squared. Okay, so I'm ready to, so I recognize a as being 5, and I'm ready to start to carry my trig substitution through. Now as I do that, I want you to notice one final thing here. Here we had x squared minus 8x plus 16, which factored as x minus 4 quantity squared. Notice the top here is just that x minus 4 quantity squared. So I'm actually going to want to write it that way as I start to carry get ready to carry my substitution through. So integral x minus 4 quantity squared over 25 minus x minus 4 quantity squared to the 3/2 dx. Okay, so this is set up, ready for the trig substitution. Since it's a squared minus x squared, that's a sign substitution. So we let x minus 4 be equal to a sine of theta. And again, we differentiate. Dx will be 5 cosine theta d theta. Okay, and then we make all of our transformations here. And it was important to have that in the form x minus 4 quantity squared so that we can substitute in for that numerator as well. So this will be integral of 5 sine of theta squared on top. So 25 sine squared theta over 25 minus 5 sine theta, so 25 minus 25 sine squared theta to the 3/2, and then times 5 cosine theta d theta. Okay, and then we start and try to work this out. So on top, I'm just going to, for the moment, put the 5 up there with the 25. That'll give me 125 sine squared theta cosine theta on top. And on the bottom here, we're going to factor out the 25. Factor out the 25, we'd have 1 minus sine squared. 1 minus sine squared is cosine squared. So this will be 25 cosine squared theta, now raised to the 3/2 power. And of course, don't forget our d theta. So now raised to the 3/2 power. So remember, when you're raising something with fractional power, do one of them first, then do the other. Here it's easiest to do the square root first. Square root of 25 is 5. Square root of cosine squared is cosine. And then we're raising those things to the 3rd power. Okay. So like this. Integral 125 sine squared theta cosine theta all over, again, square root of 25 is 5, 5 cubed is 125. Square root of cosine squared is cosine, cosine cubed. And so we simplify. The 125s go away. One of the cosines on the top cancels with one on the bottom, giving us the integral of sine squared theta over cosine squared theta d theta. But we recognize sine squared over cosine squared as tangent squared. And then it's kind of up to you how you go from here. You could invoke your reduction formula for tangent, or what I always remember when it comes to tangent squared is that I can substitute in for tangent squared, and I do that because the two pieces that I can replace tangent squared with are both things that I can easily integrate. Tangent squared is secant squared minus 1. Remember, 1 plus tangent squared equals secant squared. So tangent squared is secant squared minus 1. And then we can do the integral of secant squared. That's just tangent. We can do the integral of 1. That's just theta plus the constant. And so now we've worked the integral out. This is, again, definitely one of the harder ones to do. So we finally gotten to where we worked the integral out. And now our final step is to convert back to our original variable, which is x in this case. So we go back up to our substitution step. X minus 4 equals 5 sine theta. And we solve that for sine of theta. So x minus 4 divided by 5 will be equal to sine theta. And now we can go in and start to draw the triangle so we can compute tangent theta. Of course, the theta will just become inverse or arc sine of that stuff. So we'll draw in our triangle for sine of theta is x minus 4 over 5. So this will be square root of 25 minus x minus 4 quantity squared. Okay. Which, by the way, that 25 minus x minus 4 quantity squared, if you did simplify it, remember that stuff there is just what our original expression was if you simplified it. Or we can just leave it in that form as well. Either option is fine. Okay, and so putting this together now, tangent is opposite over adjacent. So tangent theta will just be x minus 4 over the square root of 25 minus x minus 4 quantity squared, and then minus theta, which would just be inverse sine of x minus 4 over 5. And then plus our constant of integration. All right, so we've worked that out. That's, again, definitely one of the harder ones because of first having to complete the square, and also the need to recognize that that other quantity in the top can be expressed in terms of that expression, which allows us to do a nice job on the substitution. And then it's just a little bit of detail cleaning up, dealing with tangent squared. Again, you can either use the reduction formula, or I just always recognize for that one that it's secant squared minus 1. And I can integrate secant squared and integrate minus 1.